Hello friends, today we will see about resistor. These are the basic electronic components and we are indicating that by this symbol, and we are using, if we have found this symbol in a schematic, that means we have resistor. So you can see here I'm having number of resistor. So that only today we are going to see, like what types of resistor we have and how to calculate their color coding. This is for the through hole, but we do also have some assembly components and they have different packages, so we will talk about that. First of all, you guys must have to know that if the resistor with this beige color and the resistor with this green and this blue, actually it doesn't mean anything. This doesn't have any specific thing. Okay, we can say this is carbon film resistor and this is, we can say, it's a metal film resistor. Okay, that's the only thing we can differentiate, but it actually doesn't matter with the resistance value, and color coding remains same. Sometimes on some resistors you will see four bands. Here you can see orange, orange and yellow. In some resistors you will see five bands. We can say this one brown, green, green, orange, and again there is a brown. So we have some five bands of resistor. Sometimes we see hardly this is four bands of resistor, orange, white and red, and golden is here. Sometimes we only see three bands of resistor. So what exactly that bands mean and how to calculate the value? First of all, we can say, like, if we have three bands of resistor, that means from the three bands, two bands will indicate nothing but the value, and the third one is a multiplier, 10 raised to x, and that's the multiplier we have. Okay, so in a four bands, 1 2 3 and 4, so these two indicating the value and this is multiplier, and this is the tolerance one. Okay, so in a three bands we don't have any tolerance value and we don't have anything which indicating the tolerance. In a five bands of resistor, 1 2 3 4 5, so three are the values and fourth one is multiplier and this one indicating tolerance. In some cases we have, there are six bands also, and sixth band is nothing but the temperature coefficient, it's showing that, and that are very specific resistor used where required the temperature coefficient to be considered. First three will show the value, fourth one will be multiplier, and last one is nothing but the band which will show the temperature coefficient. So this is the resistor coding. Baby Roy, Great Britain, very good wife. So here first two B's are indicating black and brown. So you have to remember this, और इसका easy तरीका है कि first में B आता है, last में W आता है. That means black and white. So in between that we have all the colors. Okay. So B Roy, Great Britain, very good wife. Okay. So this will tell you what exactly the color coding of through hole resistors, and this is applicable for all the bands. Okay, B, and that stands for brown. So remember, after black there is a brown only, not blue. Okay, so I think this will not confuse you because black, brown we can easily remember. Red, it stands for, R stands for red, O for orange, Y for yellow, G stands for green, B for blue, V for violet, G stands for gray. Okay, so and last one is the white, which we already talk about. Okay, so here we have B, so black, brown, blue, and we have G. So first G is green, and the last one next second last is a gray. Okay, so it's very easy, like BB Roy, Great Britain, very good wife. So it will help you to memorize this part. So this is BB Roy, BB Roy, Great Britain, very good. White, black, brown, red, orange, yellow, green, blue, violet, grey and white. So as I told you, this is totally depends on the color band, how many color bands we have. Okay, so this is the resistor and here we have four color bands. So for 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is the numbering sequence. So brown stands for 1, black stands for 0, orange stands for 3, and here that one is the multiplier, and the golden one is nothing but the tolerance, which we can say for, so tolerance, for tolerance we have, like if we have golden color then it is of 5% tolerance, and if we have silver color it is of 10% of tolerance. That's it. Okay, so here we have golden, that means 5% of tolerance we have. So brown, black and orange, so 10 raised to 3. So what value we will get from this? So here we can say like 10 multiplied by 1000, and it is nothing but the 10,000. That means this is 10 kilo ohm, right? Okay, we will talk about the size later on. So this is 10k. Then we have another, the one who is same like this. You can see here like brown, black and orange, and that both are 10k, but this one is different and this one is different. Now we have the resistor which shows brown, black, green, right? And silver, golden color is there, so with a 5% tolerance. So for brown we have 1, for black we have 0, and for green we have 5. So 10 raised to 5. That means how much we get? So we have to calculate this. Okay, so it's in a mega. We have to say this is 1 mega ohm. Okay, so for 1 mega ohm we have brown, black and green. We have this resistor which having 4 bands, and that's a orange. Orange stands for 3, white stands for 9 and red stands for 2. So this is the value of it, 39 multiplied by 100, so it's nothing but 3900. That means 3.9 kilo ohm. Okay, so we can easily calculate these values now. I don't think so it will that much of hard for you now. So this is the value of the resistor, where you can say like, right, so brown we have, brown stands for 1, black we have 10, 10 raised to 2 stands for red. So 100 multiplied by 10 will give you 1000. That means 1k is the value of it. So we do have number of other colors too, we can go for that. So this value we can say orange, orange and red. So orange stands for 3, so 3, 3, 10 raised to 2. That means 3.3k. Okay, then we have, okay, yeah, I simply made one circuit where positive is given to the positive of LED through the resistor, which is having the color code orange, orange, red. That means 3.3 kilo ohm. And I just connected another end of that LED to the negative of VCC. Okay, this type of simple circuit I'm using. Here I'm giving, this is positive, negative, and here 3.3 volt I'm giving. Okay, so this resistor I'm using is of different value. So this is 3.3 I have used. Now I do have some resistor that is of 10k, so I'll just replace this 3.3 ohm with 10k, and you can see the intensity. There is a difference in intensity only, because circuit will work, but as resistor increases, current will decrease. And because as you know, like according to Ohm's law is nothing but the IR. Here IR will not change throughout the circuit, so it's a nothing but the constant one. What will change? V or I. These are the value which are variable. But as 3.3 ohms, 3.3 volt I'm giving, V is again a constant, right? So R is also constant in this case. So what's the variable here is I. So I is changing as the value of, because by this Ohm's law we can say I is equal to V upon R. So resistors remain constant as current, as resistor increases, the value of current decreases, because I is inversely proportional to R. So as you can see, say 3.3 ohms I was using, that time I have good intensity. Right now the intensity is very low. Now I'm using the resistor which is having the color code yellow, violet, yellow. So we can say for yellow it's a 4, 7, again 4, so it's a 47k. So what I'm doing here with this resistor, I'm just placing this resistor between the positive. So this is the intensity I have getting for the 47k. So this is the huge, right? And if to the 47, if I replace that 47 with some other values, and that values are brown, red and orange, so we can say it's a 10 12k. So we will get the intensity, but again it's a good, okay, getting that. So I'm getting intensity quite good than 47k, but bad than 10k. And I will just replace all this with the brown, black and green. Brown 1, black 0 and green, so it will goes to, I guess this is okay. So this is nothing but the 110k. I don't think so you will get any kind of LED intensity over here. Yes, current is flowing but very low. Now I'm having 1k and I'm giving, so this is what the intensity is all about. So this is how the resistance will affect the current conduction. We can see that in a later, like how series resistance are working, how parallel resistance are working. Till now we saw like how the through-hole resistors and its values are calculated, but now these are the assembly components. These are different size of it. This is a 1206 and we have another one, and that is of smaller size 0805. So we can identify that using a spool. So we have one round shape and we call it as a spool, and on that the value of resistor is clearly mentioned, so you can read from it. And the package size is also defined over here, so you can see that the video is quite messy, but I hope you will get the exact thing what I'm trying to tell you. Thank you for watching. Please do subscribe to my channel.